And I'm presenting on my research on high-frequency transformer design. So kind of as a background, what I study is power electronics and I build power converters. So if we wanted to convert from one form of energy, like the AC that comes out of your wall, to another form, say DC, we need power converters to make it happen. They're used in a variety of different applications, from car chargers to wind farms to LED lighting, to the pumps you might find on a farm, and a million other applications too. This is an actual power converter, and what I study are magnetic components, like the big inductor that you see in the middle here. We want to optimize these power converters so they're more efficient, so that they're smaller, they produce less heat, and have lower losses. The best way to do this is to operate at higher frequencies. Modern switches, the FETs and transistors that make up all of our electronics, are getting really good for power converters because they're made out of new materials like GaN. Magnetics suddenly is the limiting factor for optimizing and building converters at higher frequencies. See, this right here on the right is kind of what a transformer, or traditional transformer, might look like. It takes the magnetic flux from the coil, which is conducting electricity, and directs it in certain ways. It couples it to a secondary. And it's critical for the operation of a lot of common converters like flyback and forward converters. We want to make this part better. We want to make sure that it's more efficient, it has lower losses, that it's smaller, and more ideal, basically. It has lower leakage inductance. So what I do is I rely on a bunch of different modern techniques for building transformers. So in this case, we change how the core is built and the materials that the core is made out of to balance how flux travels. This results in more even conduction within the wires and foil that make up the actual transformer, which results in lower loss in the end. It's really hard to analyze these transformers, so we have to rely on finite element simulation software like ANSYS Maxwell to mock up and test and analyze these structures. So just as an example, in the left you see two wires next to each other, and they're going to have higher loss because of this current crowding that happens when we put them next to each other. But if we design our transformer smartly, we can balance how flux travels and where the magnetic field is, so we get even conduction and lower loss. So that's what I'm working on. That's my spiel. Thank you for your time.